In this short video, we're going to look at solving logarithmic equations, which are equations that might look a little bit like this thing here. Now we've got to use our logarithmic properties to try and simplify this kind of thing. If you've got if it's the same base of log, we've got log base 2 and log base 2 here, then there's a way of combining these two expressions together into one logarithm, which you might remember from a previous section. That way is to combine the x and the 3 so that it's 3x. Remember, if you have log of something plus log of something else, you can combine the x and the 3 by multiplying them together to get the 3x that we have here. After that, we just have to say that the argument of the log function, the 3x, has to be equal to 24. Basically, this 3x here has to be equal to 24. And then that should be an easy thing for us to solve. We then have x equal to 8. Now, on the last page of this, of these sheets, we've got this kind of, it's actually an exponential equation as it's written just now, but we can rewrite that thing in terms of logarithms instead. Okay, so what we'll do is we rewrite it in log form. So we say 2x plus 1 would have to be equal to log base 3 of 5. Right? Again, it's just the interchanging between exponential and logarithmic forms of the equation. Now, we have two things that we could do here. We could figure out this log base 3 of 5 by using the log base function on your TI-84. You'll be able to find it if you press the math button on your TI-84 and then scroll all the way down. Most of you will have something called the log base function there. If you have an old calculator, like an old TI-83, you might not have the log base function on it, in which case you have to do something different. You would have to use the change of base formula to figure out what this log base 3 of 5 would be. You'd have to do log of 5 divided by log of 3. However, we'll assume that you'll have new calculators or the new operating system on your calculator, in which case you could just enter log base 3 of 5, subtract the 1, and then divide it by 2 to get your x. If you do that, what you should end up with is something like this, 0.232. And then example 8 is a logarithmic equation once more. Again, it's the same base here, here, and here, so you're looking for a way of combining these expressions here. It's straightforward to combine them. The log of x plus the log of x plus 4 should combine by multiplying the x times the x plus 4. So what we have next should be an equation that looks like this. And notice what we've done. The x multiplies the x plus 4 down here. And then we can look at the inside here. The 3x plus 6 has to be equal to the x times x plus 4. And that is going to be our next equation. So no longer have we got logs or anything to complicate things, but we've got quite a difficult equation here still to solve. But really, we just multiply out the brackets, we shift things over to the left-hand side, so it becomes a quadratic equation. You can do this in 2 or 3 steps if you like. And then the next step after that would be to try to factorize that. So you factorize it so that it's x minus 2 times x plus 3. So x could be equal to 2. Now you'll be thinking, okay, x can't it also be equal to negative 3 from this? Well, unfortunately, negative 3 isn't going to work. We always have to check, whatever answers we get, we've got to check them back in our equation, because if we have x equal to negative 3 from this part, it's not possible then to do log base 2 of negative 3. You can't do the log of a negative number. Okay, so you could have x equals -3, but we have to leave it out because log base 2 of -3 doesn't exist.